All right, here we are in question 1. The diagram shows the graph of y equals a sine bx plus c between negative 320 and positive 320, where a, b, and c are constants. Find the values of a, b, and c. Okay, this is a classic question, and really the key to it is trying to understand what these values here, a, b, and c, refer to. And I usually go in reverse order, so let's do that. So c, what is c? C is the shift in the y direction, and it tells you where the center line is of the graph. So by the center line, I mean the horizontal line that the graph oscillates around. So if you look at this, right, then the line y is equal to 2 is the center, okay, because the graph kind of goes, oscillates above and below it. Now, if you wanted a foolproof way of making sure you've got that right, basically what you do is you take the maximum value, which is y is equal to 6. You take the minimum value, which is y is equal to negative 2, and you find the midpoint of that. So 6 plus negative 2 is 4, divided by 2 is 2, right? So there we go. That's c is equal to 2. Hopefully that should be okay. Now, B is the one that always causes students difficulty. And the reason it causes them difficulty is because they misremember what it means. They tend to think that B is the period. Now, B is not the period, right? I want to make that very, very clear. It is related to the period, but it is not the period. This is the number of waves in 360 degrees, or if you're in radians, 2 pi radians, right? So B is the number of waves in 360. So if we've got sine 2x, that means there are 2 waves in 360. If we have sine 3x, it means we have 3 waves in 360. Now, how is that related to the period t, right? The period t is the size of one wave. Well, it's going to be related through this formula. T is going to be equal to 360 degrees divided by b. Now, why is that? Well, let's just think of our example again. Let's say b is 2. That means there are 2 waves in 360. So how big would one wave be? It would be 360, but divided by 2, right? It would be 180 degrees. Or let's say our b is 3. It would mean there are 3 waves in 360 degrees. And so what would be our t? What would be the period? What would be the size of one wave? It would be 360 divided by 3, 120 degrees. Okay, so what I want you to get is this thing here is not the period, but it can tell you what the period is here. Okay, so you want to be able to have a nice sharp distinction in your mind between what the period is and what this thing here is. All right, so how are we going to do that for this question? Well, we have to basically try to figure out what the period of the wave is, what the size of one wave is. And it's a bit hard here, but let's say we start at this point at negative 240. That's like the minimum of our wave. And we go all the way up to here to the maximum, which is at positive 240. So what's this distance going to be? From negative 240 to positive 240 is going to be half of one wave. Right? Because we haven't done a full wave. What we've done is we've done half a wave from the bottom all the way up to the top. Yeah, we need to repeat it, go from top back down to bottom. So half a wave goes from negative 240 to positive 240. So half a wave is 480. So if half a wave is 480, then one full wave is going to be 480 times by 2. Okay, so let me write that down. So the period in this case is going to be 480 degrees times by 2, which is equal to 960 degrees. Okay, so that's the period. That is the size of one wave. So the b value will be equal to 360 degrees divided by that, right? 360 degrees divided by 960. I'm just rearranging this formula here in red. And I can simplify that, right? So it's cancelled, divide both sides by 10, and then 36 upon 96, well, I can divide by 3, can't I? So I get 12 upon 32, and I can divide that again, I think, by 4. So 12 divided by 4 is 3, 32 divided by 4 is 8, so b is 3/8. Okay, so that would be my b value. All right, then lastly, what would be my a? My a is going to be my amplitude of the wave. And what is the amplitude? The amplitude is the distance from the center line up to the peak. or from the center line down to the trough. Okay, and hopefully what you can see is that that distance there is 4, right? So A is equal to 4 because the distance from 2 all the way up to 6 is 4, or 2 all the way down to -2 is also 4. Okay, so A is 4, C is 2, and B was 3/8. Okay. All right, question 2, we want to solve this equation here, giving our answers correct to 2 decimal places. Okay, before we start, this is probably a good idea to review some of the key indices rules. If I've got a to the power of x times by a to the power of y, that is equal to a to the power of x plus y, right? I add up the indices. But if I've got a to the power of x all to the power of y, then I multiply the indices, I get a to the power of x, y. And of course, one of the things you need to understand is that these rules work both ways, right? So here I've got these two numbers being multiplied, and so I can kind of combine them by adding the powers, but I could do it in reverse, right? I could take this thing here and split it up into 2 separate terms here. And that's basically what we're going to do with this expression. So if we look at this guy, 2 to the power of 2x plus 1, I'm going to split it up using this indices rule here. So instead of 2 to the power of 2x plus 1, I'm going to split it up so that what I get is 2 to the power of 2x, 2 to the power of 2x, times by 2 to the power of 1, right? So I've split that up into 2 separate terms. Okay, minus 11 times by 2 to the power of x plus 3 is equal to 0. All right, now then, this guy here, what have I got there? I am able to split this guy up in the same way. So instead of having a to the power of x, y, I could split it up to be a to the power of x all to the power of y. So what I'm going to do here is instead of 2 to the power of 2x, I'm going to change it to be 2 to the power of x to the power of 2. So I've got 3 times by 2 to the power of x to the power of 2 times by 2. Okay, minus 11 times by 2 to the power of x plus 3 is equal to 0. And I can tidy this one up a little bit. So I'm going to now change this. We got 3 times by 2 is 6. So 6 times by 2 to the power of x to the power of 2 minus 11 times by 2 to the power of x plus 3 is equal to 0. And hopefully what you'll notice is that this is actually a hidden quadratic. Okay, so I'm going to say let u equal 2 to the power of x. And if I do that, then this quadratic will become 6u squared minus 11u plus 3 is equal to 0, right? In other words, I just replace the 2 to the x with a u here and here. Now, okay, I think I can probably factorize this. So my guess is that will be a 3u and a 2u. Of course, it could be a 6u and a 1u, but my instinct says it's not. And we're looking now for 2 numbers that are going to multiply together to give positive 3 and will kind of combine to give negative 11u. So they've got to be 2 negatives, right? 2 negatives multiplied to give a positive. And my guess is that that is going to be 3 here and 1 there. Let's just think that one through. So negative 1 times by negative 3 is positive 3. And if I've got 3u times by negative 3, that's negative 9u. The negative 1 times by 2u will be negative 2u. So negative 9 minus 2 is negative 11u. So that works out all right. Now, what does that mean? That means we've got 2 solutions. The first one is going to be u is equal to a third. And the second one is going to be u is equal to 3 upon 2. And if we remember correctly, u is equal to 2 to the power x, right? So 2 to the power x is equal to a third, or 2 to the power x is equal to 3 upon 2. And of course, what we could do, if you've got a fancy calculator, you could write this as x is equal to log base 2 of a third, right? Yeah, I mean, you could do that. But, you know, I'm going to start training guys for doing non-calculator papers, and they may ask you to do it in log base e or something like that. So let's try to go through this a little bit more thoroughly. This guy I'm going to write as ln 2 to the power x is equal to ln a third, like that. And then I can use the log rule. I bring the x down to the front. So x times by ln 2 is equal to ln a third. Well, I'll write that as ln 3 to the power of negative 1, right? Because the third is 3 to the power of negative 1. And I can use the log rule here as well, actually. I can take the power of negative 1, bring it down to the front. So I get negative ln 3 is equal to x times by ln 2. And I divide both sides by ln 2. So it'll give me negative ln 3 over ln 2. And I think what I'll do is I'll just stick that straight into a calculator. So ln 3 equals divided by ln 2 equals, what have I got? And so I think that answer there should be negative 1.58, negative 1.58, which is to 2 decimal places. I think that's what they asked. Yeah, 2 dp. Okay, and then I'll do the same thing for this guy. So ln 2 to the power x is equal to ln 3 upon 2. So x times by ln 2 is equal to, well, I can split that guy up to be ln 3 minus ln 2. I mean, it doesn't really matter, actually. It'd be fine to just do ln 1.5, but I'll do it that way. And I'll divide through by ln 2. So I get x is equal to ln 3 minus ln 2 all over ln 2. And now I just got to stick this into a calculator as well. So let me do that. I'll just do ln 1.5, actually, to be honest, probably easier. Divided by ln 2. And if I do that, I get 0.58. Okay, 0.58. Now, I'll just check the answer against the mark scheme, see if those two things are right. So just give me a second to do that. Where is the mark scheme? Negative 1.58 and 0.58 are the right answers. Okay. All right, question 3. Find the coordinates of the stationary points on the curve y is equal to this thing here. Now, look, we have, to find the stationary points, right? Firstly, what is a stationary point? It is a place where the gradient is equal to 0. So let me just draw it out for you. If I've got a minimum there or a maximum there, the stationary point is that point there, and it is where the gradient is equal to 0. Right, so gradient there is 0, gradient there is 0. So when we're being asked to find the stationary point, we're really being asked to find where the gradient is 0, and the gradient is found by doing dy dx. Okay, so we got to differentiate this guy, and we've got to find where dy dx is equal to 0. That's the big picture of this question. Now, if we were going to differentiate this entire function, then we've got to notice that it is the product of two functions, right? We've got one function here, 2x plus 1 squared, multiplied by another function, x minus 3. So when we've got the product of two functions, we need to use the product rule. And the product rule, hopefully you'll remember, is v du, so vu prime, plus u dv, or uv prime. So I'm going to start by labeling each of these terms. So my u is 2x plus 1 squared, and my v is going to be x minus 3. And I'm just going to differentiate each of these separately. So u prime. So if I differentiate this guy, I differentiate the big bracket first. So the power of 2 comes down to the front, and I reduce the power of 2 by 1. So I get 2 bracket 2x plus 1 to the power of 1. Then I've got to differentiate inside the bracket, which will give me 2, and then multiply through by 2. Right, so that there is a chain rule if you're not so sure. V prime, well, x minus 3, if I differentiate it, just gives me 1. So now what I've got to do is just substitute into the expression. So v du, so I'm going to get x minus 3 times by 4 bracket 2x plus 1 plus u dv. So that's going to be 2x plus 1 squared. And of course, it's just incredibly tempting to factorize this term here and that term there. And in general, guys, if you're doing add maths, you want to be factorizing whenever you get the opportunity to do it, right? Factorize early and often is a good rule. So that's going to give us here 4 bracket x minus 3 plus the remaining 2x plus 1 term. Okie dokie. Well, then we just simplify this. So we're going to get 2x plus 1 And then 4x plus 2x is 6x. Negative 12 plus 1 is negative 11, right? So that's that. And of course, what's a stationary point? A stationary point is when y prime is equal to 0. So I set this whole thing equal to 0. So 0 is equal to 2x plus 1 times by 6x minus 11. And of course, that's got solutions when x is equal to negative a half and when x is equal to 11 upon 6. Now, guys, often students will then forget that they need to find the y coordinate, right? Now, that's always a trap. So find the coordinates means you need to find the y coordinate here as well. So if when you're doing the exam, when you first read the question and you see that, write like something like a massive y there to remind you to find them later. Because like once you've gone through all the steps of differentiation, it's just so easy just to forget, you know, because you've already done all the hard work. Okay, so the function was, what was it? Y is equal to 2x plus 1 squared, I think, times by x minus 3. Was that right? Yeah. So then I just got to substitute in the points, right? So when x is equal to negative a half, well, if I substitute that in, if I substitute negative a half into there, that term is going to become 0, right? Because 2 times by negative a half is negative 1, plus 1 is 0. So anything times by 0 is 0. So y is equal to 0. That's that point there. And then when x is equal to 11 upon 6, we've got to substitute it in a bit more carefully. So we're going to get 2 times by 11 upon 6, which is 11 upon 3, plus 1. Well, 1 can be rewritten as 3 upon 3, all squared. And then we've got 11 upon 6 minus 3. And I'm going to rewrite that 3 as 18 upon 6. Okay, so I want to make sure my fractions are all nice. Okay, 11 upon 3 plus 3 upon 3 is 14 upon 3, all squared. 11 upon 6 minus 18 upon 6 is negative 7 upon 6. So now I have just got to expand all that, and I'm going to use a calculator for that. Sorry to disappoint you. 14 squared times by 7. So on the top I get negative 1372, and I've got 3 squared on the bottom, which is 9, times by 6 is 54, and that guy should simplify. So 1372 divided by 54 is 686 upon 27, negative 686 upon 27, and if I just put that as a decimal, that is going to be approximately equal to negative 25.4 to 3 sig fig. Okay. All right. Now, by the way, the only reason I've got the decimal is because later on in part B, I've got to sketch this. So I want a rough idea of what it's going to look like, essentially. So I should probably clarify my answers, right? So I've got 2 points. So the 2 stationary points are negative a half, 0. And the other one is, what was it? 11, was it 11 upon 6? 11 upon 6, comma, negative 686 upon 27. And what I'm going to do is I'm just going to double check that against the mark scheme, make sure that I'm all right. So negative half 0, 11 upon 6, and negative 686 upon 27. All right, we're good. We're good so far. Okay, so part B. On the axis, sketch the graph of the function stating the intercepts with the axes. Okay, now look. This is a cubic, isn't it? And it's a positive cubic. So positive cubics look like that. And a negative cubic would look like that. So we know we've got a positive cubic. So that's kind of the first big point. And the second big point is we're going to know the roots of this, right? Because x minus 3 is a factor, which means that 3 is a root. So we're going to have an x-intercept at 3. So 1, oh, yeah, sorry about that. 1, 2, 3, right? So we're going to have a root there at 3. And we're also going to have another root at negative a half, right? Because 2x plus 1 is a factor. So, so negative a half is also going to be a root. But since this is a repeated factor, this is going to be a repeated root. And a repeated root means it's going to be just touching the axis, right? So we've got a root there, we've got a root there. But for this particular root, we know that it's just going to touch the axis. It's going to kind of come up and it's going to go down like that, okay? All right, now how else do we know that? Well, if you think back just a second ago, we found out that we had a stationary point when x is equal to negative a half, 0. X is equal to negative half, right? That's the stationary point. Okay, well, lo and behold, the repeated root is the same thing as the stationary point, isn't it? Because if it just touches the curve, then it means that we've got a maximum point at the x-axis there. Okay, all right, now, the other stationary point we should plot on, right? So we've got a stationary point here, 11 upon 6, negative 686 upon 27. Now, 11 upon 6, right? That's just going to be a little bit less than 2, right? So 11 upon 6 is going to be like somewhere here. So I'll put that there. Right, so I don't know, do something like that. So that is 11 upon 6. And we're looking at negative, what was it? Negative 25-ish. All right, well, I'll write it like there. So that's negative 686 upon 27. So our stationary point is going to be there. And of course, that guy's got to be a minimum because the general shape of the curve. And then last, we want to get the y-intercept. That's going to be the only other thing. So the y-intercept is when x is equal to 0. So y-intercept when x is equal to 0. So y will be equal to 2 times by 0, which is 0, plus 1 squared, 0 minus 3, so negative 3. So that thing is going to be equal to negative 3, right? So we're going to have a y-intercept at negative 3. I know this is not to scale, right? It's pretty badly not to scale, but never mind. So long as you kind of indicate all the key points, it really shouldn't matter. So let me try to draw that out now. So we're gonna go down there. Whoop. Gonna go down there. Sorry guys, I know it's not the smoothest curve. Something like that. Oh. Okay, like that. Going up like that. Like that. Okay, something like that, and something like that. Now, of course, I'm drawing on a tablet, right? So mine kind of looks a bit jagged and a bit pointy. You want to try as much as possible to have a smooth curve, guys, right? Please, nothing like that. It is just, you'll lose a mark. Okay, so try to draw as much as you can. Oh, you'll try to draw a nice, smooth curve. Yeah. Okay, so I think that should be everything. I'm going to double check the mark scheme, make sure that I haven't missed anything out. Let's see what the mark scheme says. So you get 1 mark for a correct shape with a maximum on the negative x-axis and a minimum in the 4th quadrant. Yeah. Another mark for the correct intercepts and another mark for the y-intercept at negative 3. Okay. All right. Now then, last part C. Hence, write down the values of k for which this equation has exactly one solution. Well, what is this? This is the intersection of the curve. This is the intersection of the curve y equals 2x plus 1 squared times by x minus 3. In other words, the curve we've just sketched, and the line y equals k. Now, what is the line y equals k? It's just a horizontal line, right, that goes through k. So we want to find when the intersection of this curve and this line has just got one intersection point. Well, let's have a look. If I was to draw the line going through there, how many intersection points would I have? I would have 1, 2, 3. Okay. And what if I was to draw my line going along the x-axis? How many intersections would I have? Well, I would have 1 here because I've got 1 repeated root, and another here. I'd have 2. And what if I was to draw the line here? Oh, that's a bit bad. Let me try that one more time. Like that. Okay, there. Again, I would have 2 because I get 1 intersection there, and I get 1 repeated one there. Okay, so if I just want to have 1 intersection, basically I need to be above the x-axis. So I need to be something like that. Yeah, because I need to be above this maximum point. Or alternatively, I need to be below that minimum point. Try to just extend that a little bit. I need to be below that minimum point. Okay, so essentially my k value must be greater than 0, right? So I need to be bigger than the maximum point here, which is when y is equal to 0. And I also need to be less than that minimum point, right? So I also need k to be less than negative 686 upon 27, right? And if k is one of those two values, then it means I've only got 1 point of intersection. Okay, right? I hope that was clear. All right, question 4. Find this integral, a definite integral, giving your answer in exact form. Okay, look, well, the first thing is we've got to expand this thing inside the integral. So that will be the integral of, I'll write it out in full again, 1 plus e to the 2x times by 1 plus e to the 2x. I'll do it nice and slow, dx between 0 and 2. So if I've got 1 times by 1, that will give me 1. 1 times by e to the 2x is e to the 2x. And another 1 times by e to the 2x is an e to the 2x. And then I've got e to the 2x times by e to the 2x. So I'll write that out as e to the 2x squared, right, dx. All right, then. So what's that going to give me? Well, let's simplify as much as possible. So I've got 1. I've got 2 lots of e to the 2x. So I can write 2e to the 2x. And if I square this, well, we can use the indices rule, can't I? I can do 2x times by 2, and 2x times by 2 is 4x. So that will give me here e to the 4x dx, right? If you're not sure about that, right, if I've got a to the power x and I raise it to the power of y, I multiply the indices, I get a to the power x times by y. Okay, that's what's gone on there. Okay, so now I actually need to go through the step of integration, and basically you need to remember the rule that if I'm integrating e to the kx dx, then what I get is I get e to the kx, right? So I get the same thing, but I divide through by the k. Okay, and remember plus c. Okay, so that's basically the rule that's going on. Okay, so we're going to go through each of these terms. So if I integrate 1, I get x. If I integrate 2e to the 2x, right? So I got the 2, e to the 2x, well, the e to the 2x remains the same, but then I've got to divide through by that 2, right? So divide through by that 2, that guy there. Okay, and then same thing with e to the 4x. I will get e to the 4x, but I need to divide through by 4. And I need to substitute in my bounds 2 and 0. Well, okay, firstly, I can simplify, can't I? Instead of 2 divided by 2, I'll just get rid of that, okay? There, because 2 divided by 2 is 1. So now I'm going to substitute in my upper bound. So I substitute in 2, I get 2 plus e to the power of 4 plus a quarter e to the power of 8. And then what I'm going to do is I'm going to substitute in 0. So if I substitute in 0 there, I get 0. Skip across to the right a little bit. Then I've got e to the power of 0 plus a quarter e to the power of 0. Now, what is e to the power of 0? E to the power of 0 is 1, because anything to the power of 0 is 1. So here I've got 2 plus e to the 4 minus a quarter e to the power of 8 minus 1 plus a quarter. And 1 plus a quarter is 5 upon 4, right? So we're subtracting 5 upon 4, and we've got 2 minus 5 upon 4. Well, 2 is 8 upon 4, and 8 upon 4 minus 5 upon 4 is 3 upon 4. So this is 3 upon 4 plus e to the power of 4 minus a quarter e to the 8. Okay, so that should be the exact answer, and I will just check the mark scheme, see that I am right. 3 quarters plus e to the 4 plus e to the power 8 upon 4. Did I get that right? Where have I got the negative? Sorry. I have put in a negative entirely through my own stupidity. Look, this was a positive, right? So sorry, that guy should be a positive too, and that guy should be a positive. So sorry about that. I misread my own writing sometimes. So yeah, so I've got the right answer, but a careless mistake. Actually, that is quite a good opportunity just for me to state, right? As you're getting ready for the exams, you go through the paper the first time, right? And generally speaking, if you're a good student, you should be able to finish it within about, I would say about an hour and a quarter, maybe. And, you know, what you want to do then is you want to ask for some spare A4 paper, and you just go through the questions again, because that is the best way to spot your mistakes. If you read through your own work, the chances are that you spot your mistakes actually quite slim. But if you do the question again, then you compare your answers, right? If you've got the same answer both times, then it's probably very likely that you're correct. If you get a different answer, then you want to just recheck it again and see if you can spot your error. Okay? All right. I hope that was helpful. All right, then, question 5. When e to the 2y is plotted against x cubed, a straight line graph that passes through these points is obtained. Want to find y in terms of x. Okay, if we've got a straight line graph, it's going to be in the form y equals mx plus c. Why have I written capital Y and capital X? Well, because in this case, our y is e to the 2y and our x is x cubed. Let me just undo that. There we go, x cubed plus c. Right, because we're plotting e to the 2y against x cubed. So if we want to find the equation of this line, basically what we need to do is we need to find out what the gradient is and what the y-intercept is. Well, how are we going to find the gradient? Gradient is y2 minus y1, so 7.2 minus 5 over x2 minus x1, which is 6.4 minus 2. And if we do that, we're going to get 2.2 divided by 4.4, and that's equal to a half. Okay, so therefore what we've actually got is we've got y is equal to a half x plus c. And so if we want to find the y-intercept value, we substitute in a point, and we can substitute in the 0.25. So I'm going to write that down. When x is equal to 2, y is equal to 5. And so 5 is equal to a half times by 2 plus c. And a half times by 2 is 1. 5 minus 1 is 4. So c is equal to 4. So if we go back up here, basically what we're saying is e to the 2y is going to be equal to a half x cubed plus 4. And so if we rearrange this, we're going to get 2y is equal to the natural log of a half x cubed plus 4. And so then the final answer is we're just going to divide that through by 2. So just get that, divide through by 2, get rid of that. Like that. That will be our final answer. Okay, now, part B. Want to find the values of x for which y exists. Now this is basically understanding the natural log. The natural log cannot take arguments that are 0 or negative, right? In other words, the thing inside here must be greater than 0, right? That's the condition. So a half x cubed plus 4, a half x cubed plus 4 must be greater than 0. And if that's the case, then a half x cubed must be greater than negative 4, which means that x cubed must be greater than negative 8. And in order to secure that, x must be greater than negative 2. Now, if you're not entirely sure about that as well, just because the inequality, we can just think about what the graph of x cubed looks like. Right, the graph of x cubed is going to look something like this. Ooh, beg your pardon. Looks something like that. Like that, yeah. And where is negative 8? Well, negative 8's over here, let's say. Okay, so that's y is equal to negative 8. And so if we want to have the graph being greater than negative 8, then what we require is we have x values that are here, which is negative 2, and to the right, so greater. So if we want to be greater, if we want x cubed to be greater than negative 8, so in other words, if we want to be in this part of the graph, then we require that x is greater than negative 2. Okay? Now, all right, that should be the end of that question, I think. All right, question 6. It is given that y is equal to this function. We want to find dy dx. Now, look, guys, we've got one function divided by another function, and therefore we need to use the quotient rule. So I'm going to call the top function u. So u is equal to the natural log of 2x squared plus 1. And v is the bottom function, which is x plus 2. And we can differentiate this. So we differentiate u. How do we differentiate a natural log? Well, the thing inside the natural log goes on the denominator. So we're going to get 2x squared plus 1 on the denominator. Then we differentiate that, which gives us 4x, and we stick that onto the numerator. Okay, so we get 4x over 2x squared plus 1. v prime, well, if we differentiate x plus 2, we just get 1. Now, what is the quotient rule? The quotient rule is v du minus u dv all over v squared. Now, students often get it in the wrong order. You say u dv minus v du. So make sure you got the right order. But once you know that, basically all we're going to do is just going to substitute into the formula, right? So I'm going to take my v, which is x plus 2, and times it by du. So I'm going to get x plus 2 times by 4x over 2x squared plus 1 minus u dv. So that's going to be ln 2x squared plus 1 times by 1. Okay, so times by 1. All over v squared. And our v squared is x plus 2 all squared. So we end up with x plus 2 all squared. And, you know, sometimes you need to tidy things up. I don't think it's so necessary here because you're going to substitute in a value later on. But let's tidy this up. In general, we don't like to have a fraction within a fraction. So we want to get rid of that term there, the 2x squared plus 1. So how are we going to do that? Well, basically, we multiply the entire numerator by 2x squared plus 1. And of course, to maintain equivalent fraction, we also need to multiply the denominator by 2x squared plus 1 as well. So if I was to do that, then on the numerator, I would get x plus 2 times by 4x, because the 2x squared plus 1 on the denominator cancels off, minus bracket 2x squared plus 1 times by the natural log of 2x squared plus 1. Okay, and then that's all going to be divided through by x plus 2 all squared times by 2x squared plus 1. All right, so that should be our derivative for part A. Now, part B, given that x increases from 1 to 1 plus h, where h is small, find the approximate corresponding change in y. Now, if you read a question and you see approximate change in x, approximate change in y, then basically you're going to need to use this formula. Delta y over delta x is approximately equal to dy dx. Now, I find that students don't really understand what that actually means or where it's coming from, so I'm going to very quickly try to explain now. Imagine that we've got some function, okay, like that, and so I'll draw the function. I don't know, so it looks like this. Doesn't really matter what it is. Okay, like that. And we've got 2 points, right? We've got this point here, we'll call it A, and we've got this point here, B. I'll make it a little bit closer, actually, make that there, B. Okay, and what I can do is I can draw a line that goes from A to B, like that. Okay, maybe to try to do it a little bit better than that. I think something like that. Yeah, and I think that's called the chord, something like that. Okay. Now, as well as that, what I'm going to do is I'm also going to draw the tangent to the curve at A. So I'm going to draw the tangent to A like that. Okay, so this is the line AB, and the green thing is the tangent at the point A. Okay, now let us say that the coordinate at A has just got ordinary coordinate, let's call it x, and this point here B is a little distance away from A, and that little distance in the x direction we'll call it dx. Okay, so this coordinate here is going to be x plus delta x, right? Because what I'm saying is we've moved a little distance delta x along. Okay, now if delta x is the little increase in the x direction, then we can say that delta y is the little increase in the y direction, right? So in other words, to go from point A to point B, we've moved a little distance in the x direction, that's delta x, and a little distance in the y direction, delta y. Well, what that means is that the gradient of the red line, the gradient of the line AB, right? So gradient of AB is equal to delta y over delta x, right? Because it's the change in the y direction divided by the change in the x direction, okay? Now, here is the key thing. If this delta x is small, right? So in other words, if it's really, really tiny, such that the point A is really, really, really close to A, then what's going to happen is the gradient of the red line is going to be the same thing as the gradient of the green line, right? Just kind of imagine that in your head. Imagine bringing the point B really close to A. What's going to happen is the gradient of that red line is basically going to become the same as the gradient of the green line, okay? Now, what is the gradient of the green line? The gradient of the green line is the derivative dy dx calculated at the point A, okay? So what we can say is that the delta y over delta x is basically the same as the gradient of the tangent dy dx at the point A, okay? Now, in our question that we've got here, we've got our curve. Our x value starts where x is equal to 1. So let's get rid of this. We start when x is equal to 1. And we move across a distance h. So instead of delta x, we call it h, to the position 1 plus h. Okay? So what can we say about this line here, the delta y upon delta x? It's going to be roughly the same thing as the gradient, but calculated at the point where x is equal to 1, right? So if I take the green line here is the gradient calculated when x is equal to 1, that should roughly be the same as the gradient of the red line. So what I want to do is I want to find out the dy dx value when x is equal to 1. And I'm going to do that right now. I'm going to substitute it into my derivative that I calculated in part 1, right? So when x is equal to 1, dy dx, right? So dy dx x is equal to 1, that's kind of notation, is going to equal to, well, 1 plus 2 is 3, 4 times by 1 is 4, minus 2 times by 1 squared is 2, plus 1 is 3, the natural log of the same thing, which will be 3, all divided through by 1 plus 2, which is 3, squared is 9, times by 2 times by 1 squared plus 1 is 3. Okay, and I think you can see that we can cancel everything through by dividing by 3. So divide, divide, divide. And what we'll be left with is 4 minus ln 3 over 9. Right, so if I go over here, I'm saying that this is 4 minus ln 3 over 9. Well, okay then. Using our formula or the relationship, we can say that the little change in y divided by the little change in x is going to be roughly equal to that 4 minus ln 3 upon 9. Well, what are we asked to calculate? We're asked to find the corresponding change in y. We're asked to find delta y, and we know that the delta x in this case is just equal to h, right? It's that distance there. So our delta y is going to be approximately equal to 4 minus ln 3 over 9 times by h. Okay, now I know that's quite a long explanation, and I'm sure you're thinking, this is just 2 marks, so why on earth would I go through all that faff just for that? The reason I'm doing it is because students really struggle with things that they don't actually understand, and I want you to understand what's going on. And I think this is one of the harder things really to get in the course. But the core thing is basically to see that the gradient of the line AB, so the gradient of the red line, is basically going to be the same as the gradient of the green line, which is dy dx, the tangent, so long as the distance between these 2 points is very, very small. That's the key thing. If you can get that, then I think you should be able to understand these questions quite well. All right, part C. When x is equal to 1, the rate of change of y is 3 units per second. Find the corresponding rate of change of x. Okay, what does it mean by the rate of change of y? It means dy dt. How do I know that? Well, one of the things I can do is I can look at the units. This is units per second. So this is a rate of change of y with respect to time t, right? So the change of y over the change of time. So that's equal to 3. What am I being asked to find? I'm being asked to find the rate of change of x, right? Rate of change of x. So what's that going to be? I want to find dx dt. Well, what's the relationship between dy dt and dx dt? The relationship is this. Dy dt is equal to dy dx times by dx dt. And why is that? Well, this thing here is a chain rule. And if you think about it, these two terms, these two dx's, you can imagine them cancelling off like in fractions, right? So if you want to multiply these two and you imagine that they're fractions, they're not really fractions, but we'll imagine them that way, then the dx's cancel off. Okay, so what can I do? I can substitute dy dt is 3. I can substitute my value of dy dx when x is 1, which was 4 minus ln 3 upon 9. So 4 minus ln 3 upon 9 times by dx dt. Dx dt. And so therefore, with a little bit of rearranging, dx dt is going to be equal to 27 over 4 minus ln 3. And my guess is you're going to have to give a number for that. Yeah, 9.31 or 9.32, right? That's the answer in the mark scheme. I don't have a calculator on me at the moment. Sorry about that. But you just key into a calculator, you'll get your final answer. All right. Now, one final point on this. Whenever you're doing a differentiation question, really there are only really two types of questions they ask. One is the approximate change, which is part B, which means you need to know this relationship. And the other one is rates of change, which is this relationship here, the chain rule. Students often mix them up, okay? If you see the word approximate, you're basically going to be doing that. If you see a rate of change, you're going to be doing that. Okay, so there's hopefully a quick way for you to categorize questions if you see them on the exam paper. All right, I hope that was helpful. Okay, question 7, a combinations permutation style question. We have got a 6-digit number is to be formed with these digits, 0 to 9, so 10 digits in total. The 6-digit number cannot start with a 0. Each digit can be used at most once in any 6-digit number. Well, that's true basically for all add math questions. And find out how many of these 6-digit numbers are divisible by 5. All right, so let's think about it. Here we've got 1, 2, 3, 4, 5, 6. These represent our 6 digits. What can go here? Well, basically all the digits 1 to 9 with the exception of 0. And what can go at the end? Well, if the number is going to be divisible by 5, this is going to be either a 0 or a 5. Okay, so we need to work through this systematically. And the way I'd work through it systematically is consider these two alternative options in turn. So I'm going to say the number of ways if the last digit is, okay, and let's say the last digit is 0. Okay, well, if the last digit is 0, how many ways could I choose the last digit? Well, 1, because I got to choose 0. And then how many ways could I choose the first digit? Well, I've got 9 ways, right? Because I've used the 0 here, right? Because that's already there. And so I can use any of the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So I've got 9 options for that first digit. So I can times that by 9. Now, what about the remaining digits in the middle? I've got 4 digits to place, and how many digits can I select them from? Well, I had 10 to start with. I've used up 2, so this is going to be 8. So I'm taking 4 from 8. Now, is it going to be 8p4? Is it going to be 8c4? Now, the thing to remember is, with permutations, order matters. With combinations, order doesn't matter. So does the order of the digits matter here, right? In other words, are the numbers 4, 3, 2, 1 going to be the same as 1, 3, 4, 2? And of course, the answer is no, right? Because if I arrange the order of these digits in a different way, then I've actually got a different number. So the order does matter. And so because the order matters, I'm going to have to use permutations. So this is going to be 8p4. Okay. Now, what about if my last digit was 5? Let's consider the second alternative. If my last digit was 5, there's only one way of choosing that last digit, because it's 5. How many ways are there of choosing the first digit? Well, I have the numbers 1 to 9, except the number 5, right? Because I can't choose that because I've already used it up. So actually what I've got here is I've got 8 ways of choosing the first digit. And then again, I've got to arrange 4 numbers taken from 8 numbers. So that's going to be 8p4. Now, you may be wondering at this point, why did I multiply these numbers? Well, rule of thumb, if you're going to have something and something, then you multiply. If you've got something or something, then you plus. So what I'm saying is, for the case when the last digit is 0, I want to have the last digit is 0, or the number of ways the last digit is 0, which is 1. And I also want to choose my first digit, and I want to choose these middle digits, right? So I've got this times by this times by this, because I want to have all of these things together. So it's this and this and this. But now I've got to say, well, I've got 2 different alternatives. I can either have the situation where my last digit is 0, or alternatively, I could have the last digit is 5, right? So it's either this or this. So what do I do now? Well, I add up these guys here because they represent 2 different cases, 2 different alternatives. And so 9 lots of 8p4 plus 8 lots of 8p4 is 17 lots of 8p4. And I will now key that into a calculator. I found a calculator from earlier. So let's do 8p4. And I'm going to times that by 17. And I get 28,560. Again, I'm just going to quickly check the mark scheme, make sure I've got that right. 28,560. Where are we looking? Yeah, that's exactly right. Okay. All right. So I think it's, those questions are often quite tricky. But the thing is, if you're nice and systematic, and you sort of understand the basic distinctions of, permutations and combinations in terms of order mattering or not mattering, and you understand when to multiply and when to add, then these questions can become a lot more manageable. Okay. All right. Part B. This one's quite tricky. The number of combinations of n plus 1 objects taken 13 at a time is equal to 16 times the number of combinations of n objects taken 12 at a time. Right. Now, you need to know one thing. What does NCR represent? It represents the number of ways you can take R objects from N objects. Okay? So, for example, 10C3 represents the number of ways you can take 3 objects from 10. So, another way of saying that is to say you are taking the number of combinations of n objects that are taken R at a time, right? It's kind of the way they've expressed it here. So essentially what I'm trying to say is that this thing here, n plus 1 objects taken 13 at a time, is n plus 1 CR, right? That is n plus 1 CR. That's what that means. And this guy here, combinations of n objects taken 12 at a time, is n C12. Right, that's what that means. And what we're told is that the first is equal to 16 times of the latter. Okay, so that's the first thing. It's kind of understanding what the words and the phrases actually mean. The second thing you need to know is you actually need to know the formula for NCR. And the formula for NCR is n factorial over r factorial n minus r factorial. Right, that's the formula. Okay, so what you need to do is you need to substitute these values into this formula here. So I'm going to go down. Sorry, I bunched it up a little bit. So n plus 1 CR, that will be equal to n plus 1 factorial over r factorial. And then we've got to be a little bit careful here. We've got n plus 1 minus r factorial. Okay? Oh, sorry. That r should be 13, shouldn't it? So we just delete that. I made a little mistake there. Do beg your pardon. That's 13. So let me just amend this. That guy there. That guy's 13. factorial. That's n plus 1 minus 13 factorial. Do apologize, guys. And that's going to be equal to 16 times by n factorial over 12 factorial, n minus 12 factorial. All right, now at this stage, we are going to have to simplify as much as we can. So let's do the top. We've got n plus 1 factorial over 13 factorial. Now, n plus 1 minus 13 is the same as n minus 12 factorial. And over here, we're going to get 16 n factorial over 12 factorial n minus 12 factorial. Now, hopefully what you can notice is if we multiply both sides by n minus 12 factorial, then that guy is going to disappear. Okay? So we're going to be left with n plus 1 factorial over 13 factorial is equal to 16 n factorial over 12 factorial. All right, now here comes another trick. The other trick that you need to know for these kinds of questions is the following. If I've got, for example, 5 factorial over 4 factorial, what does that actually mean? That means we've got 5 times by 4 times by 3 times by 2 times by 1 divided through by 4 times by 3 times by 2 times by 1. So what's going to happen there? Everything's going to cancel off apart from the 5. Right? So 5 factorial over 4 factorial is just equal to 5. In the same way, if I had 10 factorial over 9 factorial, that would be equal to 10. And if I had 40 factorial over 39 factorial, that would be equal to 40. Okay, so what we want to do is we kind of want to exploit that trick if we can in the algebra that we've got. So I'm going to rearrange this. Okay, I'm going to rearrange this in the following way. N plus 1 factorial over n factorial. Right, so I divide that n factorial, bring it down to the left. And I'm going to multiply both sides by 13 factorial. So I get 16 times by 13 factorial over 12 factorial. Right, so I bring that guy to the right. Now, why have I done that? Because I know that this is going to simplify to give n plus 1. And because I know that 13 factorial over 12 factorial will simplify to give 13. So in the end, I've got n plus 1 is equal to 16 times by 13. 16 times by 13 is 208. So n will equal to 208 minus 1, which is 207. Okay, let me just check that answer as well. 207. Yeah, okay. Now look, guys, that question is definitely very demanding. It requires you knowing a couple of tricks there. But they've asked it a couple of times in the last 2 to 3 years. So if I were you, I would try to make sure that you are fairly hot on that kind of question because I suspect it may well come up again. All right? Hope that was helpful, guys. All right, question 8. The line L is the normal to the curve y is equal to blah. At the point where x is equal to 2, the point negative 2k, where k is a constant, lies on this line. Find the exact value of k. Okay, look, what do we need to do? We need to find the equation of the line L, and that line is the normal to the curve. What do we need to find the equation of any line? We need 2 things. We need the coordinate point, and we need the gradient. If we've got those 2 things, then we are able to find the equation of the line because we use the formula y minus y1 is equal to mx minus x1. So that's what we want to do. So firstly, let's just find the coordinate point. We already know that the x value is 2. So how do we get the coordinate, the y coordinate? We just substitute into here. So that's what I'm going to do. When x is equal to 2, y is equal to 3, bracket 5 times by 2, which is 10, plus 6 is 16 to the power of a half. Okay, what does the power of a half mean? It means the square root. So 16 square rooted is 4, times by 3 is 12. Right, so our coordinate point we have got, and that is the coordinate 2, 12. All right, so that's all right. So the second part, how do we get the gradient? To get the gradient of the normal, we need to first get the gradient of the tangent and then use the rule for perpendicular gradients. Now, how do we get the gradient of the tangent? We need to differentiate. So we got to differentiate our function, and this guy is going to be a chain rule. So I've got to take the power of the half. So I differentiate the big bracket. I take the power of a half, bring it to the front. So that will give me 3 upon 2, big bracket, and then I subtract 1 from the power, so that will become negative a half. So 3 upon 2, 5x plus 6 to the power of negative half. And then I need to differentiate the function inside that bracket, the little function on the inside, the 5x plus 6. If I differentiate that, I get 5. So I multiply through by 5. Okay, so just to recap, right? This is a chain rule. We've got one function, 5x plus 6, which is inside the bigger function, 3 to the power, 3 whatever x to the power of a half. The way we differentiate that is we differentiate the big function on the outside first. So the power, a half, comes down to the front. We reduce the power by 1. And then we look inside the little function on the inside. We differentiate, we get 5, and we multiply through. Okay, so now we can use this to find the gradient of the tangent. So when x is equal to 2, y prime, which is the gradient of the tangent, will be equal to 3 upon 2. 5 times by 2 is 10, plus 6 is 16, to the power of negative a half times by 5. Well, I'll do 3 times by 5 over here, I think. Should have simplified that earlier. That would have been better. 3 times by 5 is 15. All right. Now, what does the power of negative a half mean? It means 1 over the square root. So this is 15 upon 2 times by 1 over the square root of 16. The square root of 16 is 4. So this is 15/8, right? Ooh, 15/8. Yeah, come on. 15/8. Okay. Now, we do not want the gradient of the tangent. We want the gradient of the normal. And we should know the rule that if two gradients are perpendicular, like the tangent and the normal, then their product will be equal to -1, right? So if I multiply the gradients, I'll get -1. Or another way of saying that is that the gradient of the normal will be the negative reciprocal of the gradient of the tangent. So it'll be -8 upon 15. In other words, what I've just done is I've flipped that fraction and stuck a negative in front of it. That's what we mean by negative reciprocal. Okay, so -8/15. Okay, so now we've got the gradient. M is equal to -8/15. Well, if that's the case, then it's just a matter of substituting into that formula there. So I'm just going to move to the right just so that I can get a bit more space. So I'm going to do y minus y1, which is 12, is equal to m -8 upon 15, x minus 2. Okay, x minus 2. And that's already the equation of our line L. And what we're told is that the point -2k is on that line. So we're going to write when x is equal to -2, y is equal to k. So we just substitute in. So k minus 12 is equal to -8 upon 15, x sorry, not x, sorry, -2 minus 2, beg your pardon, -4. I had a bit of a brain fart just then because we're replacing -2 in there. And so what's that going to be? Well, k minus 12 will be equal to +32 upon 15. And so k will be equal to 32 upon 15 plus 12. And, you know, actually 30 upon 15 is 2, isn't it? Right? So you could think of that as being 2 plus 2/15 plus 12. And so that will be 14 and 2/15 if you want to have it as kind of a mixed number. But I think I'll probably just use a calculator, to be honest. It's going to be easier. So 32 divided by 15 plus 12. On my calculator, that gives me 212 upon 15. Okay, of course, if you are doing it, you know, after 2025 and you can't use a calculator, then there are going to be tricks you can do to do that with you know, with your mental arithmetic and so on, but we'll just keep it with a calculator for the time being. And I'm going to check my answer. Yeah, 212 upon 15 or 14 and 2/15 is the correct answer. All right, hope that was helpful. Okay then, question 9 here. In this question, all lengths are in meters, time is in seconds. A particle P moves in a straight line such that t seconds after leaving its fixed point O. What does this mean, by the way? The fixed point O is where s is 0. So this whole statement means when t is 0, s is equal to 0, right? Because we're measuring time from that fixed point. Its displacement is given by this. Find the velocity of P at time t. Okay, well, let's just recap. I think it's always helpful. In these questions, you've got displacement, which is s. You've got velocity, which is v. And you've got acceleration, which is a. And basically, velocity is the rate of change of displacement with respect to time. So that's ds dt. And acceleration is the rate of change of velocity with respect to time. It's how fast my velocity is changing. So to go from displacement to velocity, I differentiate. And to go from velocity to acceleration, I differentiate. Which means to go in the reverse direction, I would have to integrate. And that's basically the key thing for you to understand. All right. So to find the velocity, what we need to do is we need to differentiate this function. So if I differentiate 4t, I get 4. If I differentiate negative 4 cos 2t, okay, if I differentiate cos, I get negative sign. So I get minus minus, right? So that's going to be a plus sine 2t. Okay, but then I need to remember, because this is a chain rule, I differentiate the 2t, I get 2, and I multiply through by that 2. So that's going to be 8 sine 2t there. And if I differentiate 4, I get 0. So my velocity should be 4 plus 8 sine 2t. Part B. On the axis, sketch the velocity time graph for p between 0 and pi, stating the intercepts with the axes in the exact form. Okay, well, look, actually, this is the same question as the very first question on the paper, right? If I've got y is equal to 8 sine 2t plus 4, 8 sine 2t plus 4, just go back to my question 1, and I kind of explain each of these things. But basically, what do these numbers here mean, right? The 8 is the amplitude, is how much the line goes up from the center to the peak and down from the center to the trough. What does this number mean? It means the number of waves in 360 degrees or in 2 pi radians. So we've got 2 waves in 2 pi radians, which means we've got 1 wave in pi radians. And what's this number represent? It represents the center line, right? The horizontal line that the graph oscillates around. So I'm saying that we've got a center line at 4. So let's put that there. That's made that 4. The amplitude is 8. So we're going to go up another 8 up to 12. And we're going to go down another 8 to negative 4. Okay, so if you want, you can sort of draw it out like that. So 4 is going to be like the center line. Okay, like that. Like that. And it's going to go up to a maximum of 12, like that. And it's going to go down to a maximum of negative 4, like that. Okay, and as I said, b is equal to 2. The period is equal to 2 pi divided by that b. So the period is pi, so we're going to get 1 full wave in pi radians. Now, each wave, right, is basically divided up into 4 kind of roughly equal parts. So I'm going to try to draw that like that. So this will be pi by 2. This will be pi by 4. This will be 3 pi by 4. So because it's a sine wave, beg your pardon, it will start here. It will reach its peak here. It will go back to the center here. It'll go down to its minimum there. And it'll go back to the center line at that point. So that'll be 1 full wave. So basically now we just need to draw the line. That'll be like that. Oh dear. Okay, I'm trying to do it as best I can, guys. Sorry, that's a bit not super nice. Like that. Like that. Oh dear. Like that. And like that. Okay. So question 1 of this paper was they gave you a graph and they asked you to find the values of A, B, and C. This question is basically the other way around. They give you the A, B, and C values and ask you to sketch the graph. Okay. Now I'm just going to check my answer for that. Yeah, that looks okay to me. Oh, but they want you to state the state the intercepts, don't they? Let me just go back to the question. Yeah, stating the intercepts of the axis in the exact form. Sorry, I did miss that. So we need to find these values here. All right, so we want to solve where v is equal to 0. So 0 is equal to 8 sine 2t plus 4. So if I rearrange that, 4, if I rearrange that, I'm going to get sine 2t is equal to negative a half. Okay, well, sorry about that. Just got a message on my phone. That means, what's the best way for me to do this, I suppose? I'll do a quick substitution, I think. Let u equal 2t. So sine u is equal to negative a half. If I was to draw the graph of the sine wave very quickly, or I could use the quadrant method here, perhaps. That might have been better. I'll draw the graph, never mind. So here's what the graph of sine u would look like. Okay, like that. Oh dear, it's not great, is it? Here, this would be pi. This would be 2 pi. This would be negative pi. Okay, we want to find out when this is equal to negative a half. So basically, what values are we interested in? We're interested in that value here and that value here. But if we were to use our calculator, what we're going to get is we're going to get that value there. And that value there on a calculator is going to be negative pi by 6. So how can we use that to find, let's say, this value? Well, this value is just one wave along, right? So it's going to be negative pi by 6 plus 2 pi. Okay, so if I add 2 pi, right, that's 12 pi upon 6 minus pi upon 6. So that's going to be 11 pi upon 6 there. 11 pi upon 6. And this guy here, well, you can use a little bit of symmetry, right? If that distance there is pi by 6, then this distance here is also going to be pi by 6 by symmetry. So this guy will be 7 pi upon 6. So essentially, our u values are 7 pi upon 6 and 11 pi upon 6. So t, we just got to divide both those by 2. So we're going to get 7 pi upon 12. Right, so that value there will be 7 pi upon 12. And this value here will be 11 pi upon 12. Okay. All right. So you can't get away with using your calculator, basically, guys, because if you're just using your calculator, you don't really know what the graph actually looks like. Then you're going to write something silly like negative pi by 6 or negative pi by 12. Okay, which is not the values that we're interested in. Okay, then next part of this. I want to find the acceleration. Well, as I said in part 1, the acceleration is the derivative of the velocity. So if we've got velocity, to get the acceleration, we just differentiate again. If I differentiate 4, I get 0. If I differentiate sine, I get cos 2t. But remember, I've got to differentiate the 2t again, which gives me 2. And I multiply through, so I get 16 cos 2t. So that will be the acceleration. That's part C. Find the times when the acceleration of p is 0 between 0 and pi. Okay, all right. Well, 16 cos 2t. So a is equal to 16 cos 2t. So we want to find when a is equal to 0. So in other words, when cos 2t is equal to 0. Well, again, when is the cosine equal to 0? If I was to draw a graph out, you guys are going to think I absolutely love graphs. I do kind of love graphs, to be honest. I just think that it basically is the best way to do it. Let me draw out the graph of the cosine, right? The cosine graph is oh, it's not very good, is it? Right, that's 2 pi. That guy's pi. This is pi by 2. And this is 3 pi by 2. Right, so, you know, all the values of 2t, if we were to follow it, 2t would be equal to pi by 2 and 3 pi by 2. And if we just kept on going, it'd be 5 pi by 2 and 7 pi by 2 and so on. If we want to find out what t is, we just divide by 2, which would be pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. But of course, we're not interested in values which are greater than pi. So, so this value disappears and that value disappears. So we should be left with pi by 4 and 3 pi by 4, I think. So let me just check. Yep, those are the two right answers. All right, guys, I think to be honest, that's less of a kinematics question. That's more of a trigonometry question. So you want to make sure that your trigonometry, particularly your graphs, is quite good because I think that's where people will lose the marks. All right, take care, everyone. Bye-bye. Okay, question 10, an arithmetic geometric progression style question. In an arithmetic progression, the first term is A, the common difference is D. The sum of the first three terms in this arithmetic progression is 42. The product of the first three terms of this arithmetic progression is negative 6720. Show that A bracket A plus 2D is negative 480. Now, okay, we could use the formula for the sum of the first n terms, but actually in this case, I think it's probably not necessary, right? The first term is A. The second term is going to be A plus D because we add the common difference. And the third term is going to be A plus D, so A plus 2D. So I think that's just easier than using the formula in this case. But of course, if you use the formula, you get the same thing, is equal to 42. And so if we did that, what are we going to get? We're going to get A plus A plus A. So that's 3A plus 3D. That is equal to 42. And of course, that's divisible by 3. We're going to get A plus D is equal to 14. Okay, so that's that. I think I'll label that as equation 1 because I suspect I'm going to use that in a second. And then we're also told that the product of the first three terms is negative 6720. Well, what's the product means? It means we multiply them. So we're going to get A times by A plus D times by A plus 2D is equal to whatever it was, negative 6720. Right, now we've already seen that A plus D is equal to 14, right? So the A plus D I can just replace with 14. So I'm going to get A times by 14 times by A plus 2D is equal to negative 6720. And I'd be very surprised if negative 6720 doesn't divide by 14. So 6720 in my calculator divided by 14, bam, 480. So I get A bracket A plus 2D is equal to negative 480. All right, now let's see. That's what we were asked to show. Okay, so I'm going to call that equation 2. All right, part 2. Hence, given that A is positive, find the values of A and D. Well, just solving simultaneous equations. I think it's probably going to be easier for us to find A first because there are going to be two answers and we'll just exclude the negative one. That'll be the easier way, I think. So A plus D is equal to 14. A plus D is equal to 14. That was equation 1. And equation 2, A bracket A plus 2D. A bracket A plus 2D was equal to negative 480. Yeah. So what I'll do is I'll rearrange equation 1. So I get D is equal to 14 minus A. And then I'm going to substitute that into equation 2. So equation 1, equation 2. So if I substitute that in, what I'm going to get is A bracket A plus 2 lots of 14 minus A, close bracket, is equal to negative 480. So that will be A bracket, we're going to get A minus 2A, aren't we? So that's going to be negative A plus 28 is equal to negative 480. And so we're going to get negative A squared plus 28A plus 480 is equal to 0. And we just times everything through by negative 1. So A squared minus 28A minus 480. And so that's a quadratic. We're going to have to solve that. One value is going to be positive and one will be negative. We need two numbers to multiply together to give 480, and they're going to add to give the negative 28. Well, I think 40 and 12 looks right to me. Of course, guys, you can use the quadratic formula if you know, plus 12, beg your pardon. You can use the quadratic formula if you're really not sure, or you can use your calculator if you're still doing the 2024 paper. But yeah, I'm basically what I'm doing is I'm looking for two numbers that multiply to give that and that are going to add to give that. So I know they need to be kind of slightly big numbers, and yeah, I just play around with it in my head. That's probably not the most helpful thing to say, but I'm kind of saying, you know, the more experience you have doing it, you'll be able to spot the numbers a little bit. Okay, so we've got a is equal to 40 and a is equal to negative 12, and basically we reject the value negative 12 because we were told in the question that our value of a was positive. Okay, all right, so then what we want to do next, we want to find the value of d. Well, d was equal to 14 minus a, so d is equal to 14 minus 40, and so that will be equal to negative 26, I think. All right, so I get a is 40, d is negative 26. Let me just check the mark scheme. Yeah, that is exactly right. Okay. Okay, then. Part B of this arithmetic geometric progression, we've got a geometric progression here. The third term is that, the 10th term is that. I want to find the first term and the common ratio. Well, we need to know the formula for the nth term of a geometric progression. The nth term, beg your pardon. And that is equal to a times by r to the power of n minus 1, where a is the first term and r is the common ratio. So the third term, u3, is equal to ar squared. And we're told that that is equal to e to the power of 4x upon 4. And the 10th term, u10, which is going to be equal to ar to the power of 9, is equal to e to the 11x over 512. And basically we've got these two equations. We've got simultaneous equations. How can we solve them? Well, if we divide this term ar to the power 9 by this term ar to the power 2, we're going to cancel out the a's, right? So that's exactly what I'm going to do. So ar to the power 9 divided by ar to the power 2 is going to be equal to e to the power of 11x upon 512 divided by e to the power of 4x over 4. So that the a's cancel off, and r to the power 9 divided by r to the power 2, we subtract the powers, we get r to the power 7. And I'm just going to write this division really carefully so people can follow. E to the power of 11x over 512 multiplied by 4 over e to the 4x, right? Because if you think about it, when we're dividing fractions, we can take the fraction on the denominator, flip it, and multiply, right? So instead of dividing by e to the 4x upon 4, we're multiplying by 4 divided by e to the 4x. Now, if I do that, e to the 11x divided by e to the 4x, we subtract the powers, so we get e to the 11x minus 4x, which is e to the 7x, beg your pardon. And then we've got, we can divide top and bottom by 4, right? So 512 divided by 4 is going to give us 128. So r is equal to, r to the power 7 is equal to e to the 7x over 128. So r, we take the 7th root of that. And if I take the 7th root of that, what I'm going to get is e to the x on the numerator and 2 on the denominator, right? So r is e to the x upon 2. And if I want to find a, I just substitute into, let's say, into u3. So ar squared is equal to e to the 4x upon 4. So a times by r squared, so e to the x upon 2 squared, is equal to e to the 4x upon 4. E to the 4x upon 4. So let's expand all that. So we're going to get e to the x squared is e to the 2x. And this is 2 squared is 4. E to the 4x upon 4. So I can cancel off the 4's, right? And multiply top and bottom, both sides by 4, beg your pardon. And so a is going to equal to e to the 4x divided by e to the 2x. And if we do that, then we subtract the powers and we will be left with e to the 2x. Okay, so my a is e to the 2x and my r is e to the x upon 2. I will just check that. e to the x upon 2 and e to the 2x. Yeah, those are the right answers. Okay. Right then, question 11. Solve the following simultaneous equations, giving your answers in exact form. And we've got these things here. Now, what we should notice is that we've got logs with different bases. So here we've got a base of 81, and here we've got a base of 9. And so what we want to do is want to change it so that all the bases are the same. And ideally, we want to have the lowest possible base. That's generally a good thing. Go from a high base to a low base. Now, what's the formula for changing base? Well, if I've got log base A, let's call it x, and I want to convert it to log base b of the same thing, then I need to divide through by log base b of the old base, right? Log base b of a. Okay, so we're going to do that here. I'm going to take, for example, log base 81y, and I'm going to try to convert it to log base 3y, and that means I've got to divide by log base 3 of the old base, which was 81. And what is log base 381? Well, it's 4, because 3 to the power of 4 gives you 81. So what we got here is we've got a quarter of log base 3y. In the same way, we're going to take log base 9x, so log base 9x, and we're going to convert it to log base 3x, which means we've got to divide by log base 39. And what is log base 39? It's 2, because 3 to the power of 2 is 9. So this is a half log base 3x. Now, once we've got that, we can just substitute into our equations, right? So we are now going to get 8 log base 3x plus 12 times by a quarter log base 3y is equal to 5. And then for the second equation, we're going to get 4 times by a half log base 3x. So 4 times by a half log base 3x plus 3 times by log base 3y is equal to 2. Okay, so these are our two equations. Now, I'm going to tidy them up a little bit. And one of the ways I'm going to tidy them up is I'm going to use a substitution. Let big X equal log base 3 little x. And let big Y equal log base 3 little y. Okay, so if I was to do that, the first of my equations becomes 8 big X plus 3 big Y is equal to 5, right? Because this is big X, this thing here is big Y, and 12 divided by 4 is 3. And the second equation, if I simplify it, gives me 2 big X plus 3 big Y is equal to 2. Right, now that should be a fairly simple simultaneous equation because I've got the same number of y's, so I can do elimination. I will subtract the bottom equation from the top, and if I do that, I will get 6x is equal to 3, which means that x is equal to a half. And if big X is equal to a half, I can substitute that in. Let's substitute into the second equation. So 2 times by a half is 1, plus 3 big Y is equal to 2. So 3 big Y is equal to 1, which means that big Y is equal to a third. So, okay, if big X is equal to a half, right, big X is equal to a half, and big Y is equal to a third, what that means is that log base 3 of little x is equal to a half, and log base 3 little y is equal to a third. And how can I convert that to indices form? Well, my base is 3, my power is a half, so x is equal to 3 to the power of a half, and the power of a half is the square root, so that's the square root of 3. On this side, my base is 3 and my power is a third, and what's the power of a third? It's the cube root. So our two answers are the square root of 3 for x and the cube root of 3 for y. And let me just check that in the book. Yep, that's the right answer. Okay, so a little bit of manipulation, hopefully you should be able to get the answer there. Although I think that question is a little bit tricky. Okay, then the last question on the paper, a trigonometric question. Solve this equation, beg your pardon, solve this equation for between pi by 2 and negative pi by 2, giving your answers in exact form. Now, the way in which I do this is quite long. and consequently, a lot of students tend to, complain that they don't really like it. But what I would say is the way I do it is long, but I get the right answer, and I know that I've always got the right answer because my method is clear and it's meticulous. So if you're the kind of person who is always getting the right answer and you're happy to do it the fast way that then yeah, of course, by all means do that. But if you find that what you're doing is you're doing it the fast way and you're getting it wrong, or you're not getting all of the answers, or you're not sure if you've got it right or not, then can I just suggest to you, slow down, make your number one priority getting it right. Okay, and the method I'm going to do here should guarantee that you get it right. All right, so how am I going to do that? First job is I'm going to do a substitution. I'm going to say let u equal 3 theta minus pi by 2. Now, the reason I do that is because I convert the problem to be sec u is equal to 2. And of course, sec is 1 upon cos, right? We always look at the third letter, 1, 2, 3, c. So sec is 1 upon cos. So this guy here is actually cos u is equal to 1/2. And a lot of students then just jump immediately and say, well, I'll use my calculator. And so u is cos inverse 1/2, which is pi by 3. Okay, I'm not going to do that at the moment, because what I want to do is I want to pay attention to the domain, the set of values that I want. Now, I know the domain for theta, but what I would like to do is I'd now like to know the domain for u, right? Because that's going to help me to get the right answers. So the way I'm going to do that is I'm going to rearrange this guy here. So that's going to give me 3 theta is equal to u plus pi upon 2, right? So add pi upon 2 to both sides. And that means that theta is equal to 1/3 of u plus pi by 6. Okay, so I've rearranged to get theta in terms of u. Well, if that's the case, I can put that into this domain here. So instead of having minus pi by 2 theta and positive pi by 2, I'm going to replace the theta with 1/3 of u plus pi by 6. Okay. And I'm going to now rearrange this. So the first thing I'm going to do is I'm going to subtract pi by 6 from every part of the inequality. Okay, now just to make that a bit clear, to sort of clarify this, instead of pi by 2, I'll make that negative 3 pi upon 6, and this guy will be positive 3 pi upon 6. Right, so now if I subtract pi by 6 from both sides, this becomes negative 4 pi upon 6. And this side becomes 2 pi upon 6. Oh, beg your pardon. 2 pi upon 6. And this becomes 1/3 of u. Okay, well then what I want to do is I want to multiply everything through by 3. So if I do that, this will become minus 12 pi upon 6. And this guy will become 6 pi upon 6. Well, then what is that? That's saying that 12 pi upon 6 is just 2, isn't it? 12 divided by 6 is 2. And 6 pi divided by 6 is just pi. So in other words, what I'm really trying to do now is I'm trying to solve the simpler problem of cos u is equal to 1/2 between negative 2 pi and positive pi, right? So I really want to kind of highlight to you that I have converted the problem into this different, but actually slightly easier problem for us to solve. Okay, so I've converted from theta to u. All right then, now how can I solve this? I could solve it using the unit circle method, but what I'm going to do is I'm going to use a graph for this particular case, right? Sometimes I think it's easier to use a graph, sometimes it's easier to use the unit circle. I don't think it really matters, but I'm gonna use the graph here. All right, so pi by 2, pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, right? So minus 2 pi, minus pi, and this is pi here. Right, now what does the cos graph look like? It starts at 1, and it kind of looks something like this. So it's gonna go down, like that, like that, like that, like that. Okay. Sorry about the slowness in drawing this, but I want to try to make it look reasonably nice. Okay, and like that. Okay, so that is the graph of cos u. And notice that I've drawn it between negative 2 pi, and positive pi. Now I want to find when this graph is equal to a half. So that's the same thing as asking when this graph intersects the line y is equal to half there. So that's a half. So where does it intersect? It intersects at this point here, this point here, and this point here. So I'm looking for 3 solutions for u. Now, if I was to use my calculator, cos inverse, I'm going to get that first value there, and that value is pi by 3. Now, by symmetry, that value must be negative pi by 3, right? Because it's a reflection in the y-axis. But what about this value here? Well, this value, you can think of it, is kind of like the same as that value. It's just one full wave to the left, right? So what I've done is I have moved one full wave to the left. So that's going to be pi by 3 minus 2 pi, right? Because one whole wave is 2 pi radians. So we're going to get pi by 3 minus 2 pi. So pi by 3 minus 2 pi. Well, 2 pi is the same as 6 pi upon 3. Right, 6 pi upon 3. So pi by 3 minus 6 pi upon 3 is minus 5 pi upon 3. So we've got that value there, minus 5 pi upon 3, right? That's that guy, right? Minus 5 pi upon 3. And we've also got the value negative pi by 3 and positive pi by 3. Now, these are the values for u, but what we want is we want the values for theta. And theta, if you remember, is a third of u plus pi by 6, right? So theta is equal to a third of u plus pi by 6. So what I need to do is I need to take each of these values, divide by 3, and add pi by 6. So let's do that. So then u, if I take negative 5 pi by 3 and divide by 3, I get negative 5 pi upon 9, and I still need to add pi by 6. Okay, and then I've got the other value, negative pi by 3. Well, if I divide that by 3, I get negative pi by 9, and I've still got to add pi by 6. And then lastly, if I've got pi by 3 and I divide by 3, that's pi by 9, and I've still got to add pi by 6. So now the last step I've got to do is just got to do a bit of fraction work. What's the common denominator of 9 and 6? It's going to be 18. So I'm going to times the first fraction top and bottom by 2, so negative 10 pi upon 18. And the next fraction top and bottom by 3 pi upon 18. Same thing with this guy, so that'll be minus 2 pi upon 18 plus 3 pi upon 18. And same with this guy, 2 pi upon 18 plus 3 pi upon 18. And now if I go through, my final answer for these will be negative 7 pi upon 18. This one will be pi upon 18. And this guy will be 5 pi upon 18. Okay, so not only do I know using my method that I've got 3 and only 3 answers, I've got a pretty robust way of being able to calculate each of those answers. So let me just check the mark scheme. I want to make sure that I'm right. Negative 7 pi upon 18, pi upon 18, 5 pi upon 18. Okay, right. So as I said right at the very beginning, I know that that is a long way. I know, but I get the right answers. And that's the thing I really want to drill in and highlight is your goal is not to be fast before you are accurate. You must be accurate first. If you are accurate and you're always getting the right answer, then you can do it faster than me. Sure, you can use the quadrant methods and all that. But first, make sure that you are right and you know why you are right. And what I've tried to do here is to give you a rational, robust, clear explanation of every single step that I've done and why I've done it. And I think that really you should be trying to do the same thing as much as possible, because even though it is hard, it makes your life a lot easier in the end. Okay, good luck, guys. By the way, if you are finding these videos helpful, please do like and subscribe and share them with your friends. I hope to reach more people and encourage them to be even better at maths.